Today we are going to find the mean and variance. Actually, it is a mathematical expectation of random variable and variance of the random variable for the given value of probability density function. Now, our question is the probability density function is in the form of exponential form, that is k time e to the power minus 5x for the range 0 to infinity 0 otherwise. The question is find the value of k if the given fx is probability density function, and we are going to find the mathematical expectation of this random variable as well as the variance of the random variable. For the solution of this function, we have a function fx of a continuous random variable x is said to be probability density function if it satisfies the following two conditions. The first condition is the function fx is positive, that is non-negative, for all value of x belongs to AV. The range may be closed interval or one close or other. In our cases, the 0 is close and infinity is open variable, and that is the second condition is minus infinity over that is entire range fx dx is equal to 1. From this condition, we have the two function for minus infinity 0 fx dx, the function is 0, and 0 to infinity fx dx is the function is defined. So it gives the first part is 0 and the second part is over 0 to infinity k time e to the power minus 5x dx. The integration of this exponential function is simply this e to the power k time e to the power minus 5x by 5. The integration of e to the power ax dx is simply e to the power ax by divided by a. So it produces the value of constant k is equal to 5. Therefore, the probability density function becomes 5 times e to the power 5x over the region 0 to infinity and 0 otherwise. The next part is we have to find the mean or average or the mathematical expectation of random variable. For this, we have the formula expectation of x is equal to integration over region a to b x time fx dx. But after putting the value of fx, the 5 times e to the power minus 5x, then we can integrate the term x time e to the power 5x dx. For this integration, we can integrate by part, but the integration by part lead to the improper term. The first term for the upper limit infinity become improper, so we have to use the gamma function. uh, for this, let 5 of x is equal to t. On differentiation, it gives 5 times dx is equal to dt. When the range of x is equal to 0, t is tends to 0, and when x is equal to infinity, the value of t is equal to infinity. Then this integration becomes 5 times 0 to infinity, and the value of x is t to 5. The 5 of x becomes t, and dx become dt by 5. Okay, separate the variable. The t become t to the power 2 minus 1 and e to the power minus t. This integration is similar to the gamma function, 0 to infinity t to the power n minus 1 e to the power minus dt is equal to gamma n. Then this leads to the 1 by 5 times gamma 2, and the gamma 2 is 1 factorial, and this is equal to 1 by 5. So the mean or the mathematical expectation of this random variable is equal to 1 by 5. Now the variance of this random variable, we have the formula variance of x is equal to expected value of square minus square of the expected value. The second part is already calculated, 1 by 5 square. For first part, we have formula x square times fx dx. After substituting the value of fx 5 times e to the power minus 5x, for this integration, x square times e to the power 5x, we have the similar argument. The integration by parts leads to the improper term, so we have to use the gamma function. And for this, let 5x is equal to t, 5 times dx is equal to dt. When x is equal to 0, t tends to 0, and when again x is equal to infinity, t is equal to infinity. The variance become 5 5 times 0 to 5, x square tends to t by 5 whole square, e to the power minus 2, and dx tends to dt by 5 minus 1 by 25. And after simple calculation, the integration become t to the power 3 minus 1 times e to the power t dt. For this color integration by using gamma function, it gives the value of the gamma 3, and gamma 3 is equal to 2 factorial, and it produced the value of value is equal to 1 by 25. So the variance of this random variable for the given probability density function is 1 by 25.